So last time the recap, which is that I explained to you what buffers were, right? यहाँ से. ठीक है, I explained to you what a buffer solution is. I told you that a buffer solution is something that is going to resist a change in pH when a small amount of acid or alkali is added to it. Okay, so it's not going to let the pH change. It will maintain the H plus 1 concentration. So it's going to maintain the balance of H plus 1 and OH minus 1. Okay, so it's not going to allow it to change. And that is very important because I had explained to you that that a lot of systems around you, they are very sensitive to this balance of H plus 1 and OH minus 1. If you change that, they would stop working. Every system has its own preferred pH at which it's going to work. So how was the buffer formed? That it was formed when you had a weak acid and you mixed it with its conjugate base. Okay? So for example, if you have etheric acid and you mix it with the conjugate base, which is etheroid ions. Okay? So whenever etheric acid dissociates, this is the base because why it's the base? Because it's able to accept the H plus 1 ions. And that's your acid, right? The reason that's your acid is because it's capable of releasing H plus 1 ions. So you've got a weak acid and you've got its conjugate base. So आपको दोनों चाहिए होते हैं. And if your solution has both ions, not both ions, you've got the conjugate base and you've got the weak acid as well. If you add H plus 1 ions to the solution, you try to increase the concentration of H plus 1, what happens is those H plus 1 ions go into the solution and they get attracted or they get neutralized by the base. यहाँ पे equation भी लिखी हुई थी. So if you are adding H plus 1 ions to the solution, there's going to be a lot of H plus 1 ions. Even if you try to add some H plus 1 ions, those H plus 1 ions will be accepted by the conjugate base, and the H plus 1 ions are going to be accepted by the conjugate base, and they would get neutralized. Okay, they're going to get used up. So you will not be able to increase the concentration of H plus 1 ions. Vice versa, if you add alkali to it. So if you add a lot of OH ions, so what happens that the weak acid, it starts to release H plus 1 ions, and those H plus 1 ions are going to neutralize it. So if you add OH ions, the etheric acid, which is the weak acid, it's going to release H plus 1 ions, and your OH ions are going to get neutralized to water, and etheric ions would be produced. So all your alkali that you were trying to add to the solution, that will get neutralized. So buffer solutions have a base and they have an acid, and therefore when you add an acid or a base to it, it eventually gets neutralized. ठीक है? ये clear है? Is this thing clear? सारों को कल क्या था? Ibrahim, is this clear? Rumesa, Minal, Ala, is this clear?
Yes.
अच्छा आगे ये कि अच्छा, so what I told you was that for a buffer to be formed, you need a weak acid and you need its conjugate base, right? So you need etheric acid and you need etheric ions as well. But I told you specifically that etheric acid on its own, it's a weak acid. It does dissociate, but it doesn't really produce a lot of etheric ions. So the trouble is that etheric acid on its own will have very, very few etheric ions. So these ions over here, you have to add extra ions in your solution. And how do you add extra ions? You add a salt of etheric ions, of etheric acid, okay? For example, these ions are going to be produced. You have to produce these ions. So if you add a salt of etheric acid, then that salt is going to have a lot of those ions. And so therefore, you would need to add extra amount of etheric ions. So this has to be added. This needs to be added. So your buffer solutions are normally formed when you have etheric acid and you have the conjugate base. And where is the conjugate base coming from mostly? It's coming from the salt of the weak acid, okay? And then I talked about the expression as well for your dissociation constant, which was our equilibrium. Since our equilibrium reaction remains for the weak acid remains exactly the same, so your dissociation constant value remains exactly the same as well. But the only difference I told you was that these two ions are no longer going to have the same concentration. They are not going to have the same concentration. एक second रुकना. अच्छा, so the trouble is that these two ions are no longer going to have the same concentration because you are adding extra amount of salt to it. So your expression, your K expression only changes very slightly, which is that previously हमारा जो dissociation constant was that these two ions had the same concentration. We had the habit of writing H plus 1 squared instead. The product concentration divided by the reactant concentration, that was our equilibrium constant for acid dissociation. And you were able to write H plus 1 squared. Why? Because both of them had the same concentration, which is not going to be the case anymore. And this ion is being produced from the salt. So you're going to add the salt concentration to it, okay? So I'm going to do one question. That's the only difference. Your K just changes very, very slightly. You still have the same reaction. You still have the same Ka value. The only difference is that these two things are no longer have the same concentration. So we're going to do a question now. Or question ye ki, let's say I'm going to make a simple buffer. Calculate the pH. Of a buffer. Now, the buffer has etheric acid. And let's say its concentration is 0.15 mole per dm cube. And the same buffer has the salt as well, which is basically the conjugate base. And its concentration is 0.10 mole per dm cube. And the K value for etheric acid is also given. And let's say that's 2 times 10 power minus 6. So they're asking me to calculate the pH. So I'm just going to use the expression, which is that if you're dealing with etheric acid is going to dissociate. It's going to be in equilibrium with etherites and H plus 1 ions. It's going to have a K expression, which is going to be. Okay, so there's going to be a K expression. And that K expression would be etheric concentration times H plus 1 concentration divided by, you're going to divide that by etheric acid. I have the K value. 2 times 10 power minus 6. So I have that. I have the etheric concentration, which is 0.1. And I have the etheric acid concentration, which is 0.15. You put given it here, that's 0.15. And all I need now is the H plus 1 concentration. So using that K expression, I will be able to figure out the H plus 1 concentration. ये मुझे बताना कि what do you get for this? Minal, do you have a calculator with you, Hala? Ibrahim? 2 times 10 power minus 6 times, I think 15 over 10, right? Yeah, what do we get?
Three multiplied by 10 raised to power minus 6.
3 multiplied by 10 raised to a minus 6. And take the negative log now. So we get the pH as well. Or just take the log. What do we get?
5.52.
You get 5.5. Yeah, that's my pH. To be clear, it's not that difficult. It's a simple question. You had
Sir,
your
it's minus 5.52.
नहीं वो negative log लोगे ना, so that's why you get rid of the negative sign. हालांकि clear है?
Okay, sir.
वो I mean negative log में negative डालने का सिर्फ वही issue था that you get rid of the negative sign. अच्छा, so that's it. ठीक है, that's your question, but the question is not going to be that straightforward. The only thing you just need to worry about is, I mean, there's only just one minor difference, and that is these two ions are no longer having the same concentration. That's it. Okay, this is the concentration of the conjugate base. This is going to be the concentration of your weak acid. So I'm going to do another question. Okay, see the past paper speaker. So we're going to open past paper questions for buffers now. So yeah, we did this one last time. Okay, so this one. We're just going to focus on buffer. So what he's doing is he's creating a buffer solution. So a buffer solution is made by mixing ammonium chloride and ammonia. So ammonium chloride has ammonium ions and there is ammonia, right? So it's a weak acid and it's conjugate base. It's definitely a buffer. This is the equilibrium reaction. The ammonium ions are going to lose or produce H plus ions. And let's say disconnect to get हमारा ये so this one. So I had a question, which is that they told us that the buffer is being formed and you had ammonium ions and you had ammonia. So I was able to figure out that this is my weak acid because it's the one that's going to produce H plus ions. And that, on the other hand, is my conjugate base because that is capable of accepting H plus ions. It's going to accept H plus ions and this is going to produce H plus ions. Okay, with the aid of an equation, how this solution can behave as a buffer, right? When a small amount of acid is added, right? So you're adding an acid with the help of an equation. So if you add an acid, who's going to react with it? Well, it's not going to be the acid, it's going to be the conjugate base that's going to react with it. So the ammonia is going to absorb it and it's going to form ammonium ion. So the H plus one is eventually going to get neutralized, right? And the same thing with the aid of an equation, how would it act as a buffer if a strong base is added to it? So if you add OH ions, that's a base. So the acid is the one that's going to neutralize it. So now what's going to happen is that the NH4 plus 1 is going to release an H plus 9. So it's going to turn it into water and ammonia is going to be produced. So these are simple equations. You just need to practice this a lot. They're going to ask this equation a lot of times. So if he's adding acid to it, the conjugate base is going to accept it and turn it into NH4+1. If he's adding an alkali to it, the weak acid is going to release an H plus ions. So the H plus ions are getting absorbed. Over here, this is releasing H plus ions to neutralize the OH ions. Okay, is this clear? Ibrahim, Isaac, is this clear? Is that clear? Minal?
Yes.
Acha, ye करके forget that buffer. Let's do that's KP. Okay, this is similar. He's saying the first thing. He's saying use mathematical expressions to define the following term. Just the mathematical expression. So this is minus log of the concentration of H plus 1. And K for a weak acid like HA, uski equation kya thi? It's the weak acid dissociates, produces H plus 1 and A minus 1, right? So your K expression would be H plus 1 concentration times A minus 1 concentration divided by the HA concentration, right? Now he's saying write equations to show how a buffer solution consisting of a mixture of HA, which is this, and NaA. NaA is basically A minus 1. You do NaA, and that's, remember, Na is just a spectator, right? Na is not really doing anything. The important thing is it's got A minus 1. So we've got a weak acid, and we've got the conjugate base. The book he's saying show with equations how it's going to act as a buffer. So if acid is added, who's going to accept the H plus 1? So H plus 1, you just added H plus 1. Who's going to accept it? It's the conjugate base that is going to grab it. Pata lagana easy is because it's got a negative ion. So the negative ion is the one that's actually going to accept the H plus 1 and it's going to form HA. If base is added, so who's going to neutralize it? It's if you add a base, the weak acid is going to neutralize it. So that is the one that's going to release the H plus 1 ions, turn it into water, and you're left with A minus 1. So your H plus 1 and your OH ions, both of them are getting neutralized by the buffer that is formed by these two ions. Okay, is this clear?
Yes.
Ab aa jao. Now the next one, that's going to be a pretty difficult question. It's a moles question, but I think it's a buffer solution question as well. How many marks is this? This is 3 marks. But it's a so now this is a very a moles question that is mixed with a buffer solution question. So you have to think about it very you would have to listen to this very carefully. So he's saying when solutions of chlorine are used for water purification, the pH of the solution of chlorine is kept near to pH 7 by the addition of a base. So anyways, they're kind of creating a buffer, right? So chlorine is dissolved in water to form a 100 cm³ solution containing 0.17 moles of HClO and 0.170 moles of HCl. So I'm going to write down the moles. 0.170, I think, moles of HClO. And they've dissociated HCl. I mean, they're showing that HCl is like a strong acid. Although we know it's a strong acid. But they've shown it dissociated. I mean, this is an acid as well, but it's not dissociated. So this means that it's probably a weak acid, and this means that it's probably a strong acid. So this one is the weak acid because it's not dissociating. And this one is fully dissociated, so that's probably a strong acid. As a volume, we note kar volume of the solution is 1000 cm cube. So he then says a buffer solution is then prepared by adding 0.2 moles of NaOH. So in this mixture, they are now adding 0.20 moles of NaOH. Okay, that's being added. So 0.2 moles are added. And the NaOH reacts initially with HCl. So initially, right at the beginning, it's these two that are reacting together. The HCl is reacting with the NaOH. So they told us. So I'm going to write a quick reaction, which is that HCl reacts with NaOH. And it produces what? NaCl plus H2O, right? So this HCl over here, which I'm going to highlight, it initially reacts with NaOH. Now, listen to this carefully, that the amount of HCl is 0.17 moles, right? And the amount of NaOH is 0.2 moles. So that kind of shows that the HCl is going to completely react. 0.17 is going to react with 0.17. So that means 0.03 moles. So 0.03 moles of NaOH are still left, right? And all the HCl is gone now. So is this clear that 0.2 moles of NaOH were added? So all the 0.17 moles of HCl is used up. But there is still 0.03 moles of NaOH still left after the reaction. Get it?
Yes, sir. Yes.
अच्छा ये हो गया. अच्छा now, so initially it reacted with that. Well, what's now going to happen is they didn't write any other story after that. But the thing is, there's another acid, which is this one, that is still present. So that means there's definitely going to be another reaction because that NaOH is going to react with something else. So after the first reaction, there's going to be another reaction, which is that HClO, which is 0.17 moles, will react with the leftover NaOH, which is how many moles? 0.03 moles. The two are going to react. The HClO is going to get neutralized, so it's going to become NaClO. And H2O would be formed. Remember, the H and the OH will react together to form H2O. And Na and ClO would form the salt. Okay. So what you had was that you had 0.03 moles of NaOH that was still left. And they ended up reacting with the HClO that you had in the solution. So now, which one is in excess? It's 1:1. Now, NaOH is going to completely react. It's going to go. Either 0.03 moles would be left or react. So 0.17 and then minus 0.03 out of it. So that means you're left with 0.140 moles, right? And 0.03 moles are going to react with 0.03, and on the other side, they're going to produce 0.03, right? So is this part clear?
Yes.
Or in my simple terms, I'm going to explain this again, that you had 0.17 moles of HCl and you had 0.170 moles of HClO. You added 0.2 moles of NaOH, it reacted with 0.17, 0.03 moles were left. That 0.03 moles then went and reacted with the other acid. So 0.17, 0.03 reacted with 0.03, 0.14 were left, and 0.03 would be produced. Now we're saying calculate the pH of the buffer solution. So where is the buffer? I mean, we look at the end point, which is this. That you still have the weak acid and you have the conjugate base as well. So it is a buffer. What is a buffer? A buffer is formed when you have a weak acid, which we do have in our case, 0.14 moles of it. And we also have its conjugate base, which is ClO minus 1 or NaClO minus 1, which is 0.03 moles. And we also have the Ka value for this weak acid. So I'm going to write down the expression of this weak acid, which is HClO, in equilibrium with ClO minus 1 plus H plus 1. I know what the K expression is. Let's write the K expression over here, which is ClO minus 1 concentration times H plus 1 concentration divided by HClO, or the acid concentration. So we're going to plug in the values, which are what, 2.9 times 10 raised to power minus 8. And ClO minus 1 is 0.03 moles. And this is 0.14 moles times H plus 1 concentration. Now, typically you don't use moles in the expression. But over here, you can use moles because since how do you calculate concentration? You're going to divide by volume, right? But the problem is that both of them are the same solution. So the volume term would get cancelled out anyway. So in this particular case, you can actually use moles directly. So try and calculate this one. This would become 14 over 3, right? So find out what H plus 1 is and find out what pH is. Anyone try and do this quickly? Hala, middle.
Say 1.35
pH.
times 10 to the power minus 7.
But take the negative log as well.
Oh.
6.87.
Yeah, so we're getting 6.87, right? So that's our pH. Anyway, so that's a pretty tough question to follow because you had to do the moles part first, and right at the end, you were able to form the buffer. But is the question clear somewhat? Clear? Can you clear?
Yes, sir.
Okay, so sometimes
Yes.
they'll mix moles with buffer. So let's try and find another question. So here's another buffer. This is a moles question as well. Like, let's do the whole question. So this is organic, so I'm just going to skip that. He's saying calculate the pH of ethanoic acid. 0.1. So it's, so now this is not a buffer. So this is just pure ethanoic acid. It's not a buffer. So ethanoic acid, it's going to dissociate. It's going to produce CH3CO minus 1 ions, and it will produce H plus 1 ions. And since you just have a weak acid, both of these ions will have exactly the same concentration. So your K expression would be product concentration, H plus 1. You can square it because both of them have the same concentration. Divided by the acid concentration, which is CH3COOH. So what do we need to find? The K value, I think, is given over here. That's it's 1.75 times 10 power minus 5. Okay, the concentration of the acid is also given. That's 0.1. So I'm just going to take 0.1 to the other side. And it's H plus 1 squared. So I'm going to underroot this side. What do we get now?
1.32 times 10 to the power of negative 3.
And calculate the pH now. Take the negative log of that.
2.87.
2.88.
Okay, 2.88. So anyway, so that's what your pH is. But remember, you had to be careful that when they're talking about just a weak acid and when they're talking about a buffer. Okay, a buffer would be formed when they had ethanoic acid and they had added this ion as well from somewhere, from the salt or coming from somewhere. Then it's a buffer. which is the next part. It's again a moles question, but it will end up forming a buffer. And so what's happening is, as in this case, what's happening is that there is, so they're not even going over there, but we'll do this anyways. So he said that etheric acid is reacting with NaOH. You got NaOH, you got etheric acid. The two of them are reacting together, and they would form a salt and a water molecule. Okay, so that's done. Now, we can calculate the moles of NaOH. That's volume times concentration. So this, I think, would be a volume times concentration. That's going to be 2 times 10 power minus 3 moles. Or somebody double check this. You get concentration times volume. And etheric acid is this. It's 10 into 0.1 wet by 1,000. So that's how much? That's 0.001 moles, right? But it's not a buffer, because if these two react, the etheric acid is going to completely react. One will react with one. There would be NaOH still left. So half of it would still be left. And 0.001 will react with 0.001, and it's going to produce 0.001 moles of this and 0.001 moles of this. Now, this is not a buffer because all the acid is gone. For a buffer, you need the weak acid, so it's definitely not the buffer. So what he's asking for is calculate the OH ion concentration. So we know that there is some OH ions that are left. So how do you calculate the concentration? Concentration is moles over volume, right? So we know 0.001 moles of OH ions are left. What is the volume of the solution now? So remember this as well, that when you mix two solutions, so there was a 20 cm cube solution that was mixed with a 10 cm cube solution. So when you mix two solutions together, the volumes, they get added up. So the moles that you have of NaOH that are left, they are now in a solution whose total volume is now 30 cm cube. Okay, when you mix two things, the volume of the solution adds up. So that's 30 dm cube. 30 divided by 1,000. That's I think that's 0.03 dm cube, right? So what do we get? 0.33 or 0.033?
0.033.
So this is 0.033 mole per dm cube, right? Okay, so this part wasn't really a buffer solution question. It was more about just calculating the OH ion concentration. And in the next part, he's asking you to, because since we calculated the OH ion concentration, he's now asking us to calculate the H+1 concentration using this expression. So I told you that H+1 times OH ions, that's always equal to Kw, which is what? 1 times 10 to the power minus 14, right? We've now figured out the OH ion concentration. So my H+1 concentration is 1 times 10 power minus 14 divided by 0.0333, right? So find this and find pH.
3 times 10 to the power of negative 13.
And what's the pH?
pH 12.5.
12. So pH is 12.5. Okay, this one was a slightly different question. They were just asking you to calculate the pH. We haven't done the sketches yet, so I'm going to ignore that. Just want to find out more buffer questions. No, not this. Okay, here's another difficult question. Not really a difficult question. It's a buffer because he's adding the salt of ethanoic acid and the ethanoic acid. So a buffer solution is to be made. So they're making a buffer solution. And they're adding ethanoic acid. How much? 1 mole per dm cube. And they're adding the other one, which is the salt. Remember, Na+1 is just as spectratines, basically ethanoic. And that is also given as 1 mole per dm cube, right? So he's mixing the two together. So calculate to the nearest volume. They've given the pH of the buffer as well. So the pH of the buffer is known. The pH is 5.50. Now, and you're required to make a 100 cm cube buffer. So I know the volume as well. The total volume is what? 100 cm cube. The pH of the buffer is 5.5. So all the information given, the K value is also given, right? So calculate to the nearest 1 cm cube the volumes of each solution. So what you don't know is what is the volume of this solution that needs to be added and what is the volume of this solution that needs to be added to it. To make a buffer that has a pH of 5.5 and has a total volume of 100 cm cube. So that's the question. So, and you have to figure out the volumes that are going to mix up. And so the first thing is, the first thing is, the volume is the thing that you're trying to find. So volume is the X, right? Volume is the unknown. So the volume is what? What is the volume of ethanoic? That's X cm cube. So what would be the volume of the other, of the weak acid that you're mixing? That volume would be 100 minus X cm cube. So listen to this carefully, that since the total volume is 100 cm cube, they told us the total volume is 100 cm cube. If I take this as X cm cube, then the other one would be what? 100 minus X cm cube. Is this part clear? Professor, middle, Hala, is this clear? Very clear?
Yes.
So that's the first part. So, and the remaining stuff is that, you know what the equilibrium is? So you know what the equilibrium is, and that's this. So what is the buffer? What is the expression for dissociation constant? That's the salt concentration or the conjugate base concentration times your H+1 concentration divided by your acid concentration. So now the stuff is easy because you have the K. So I'm going to plug in the K, which is what? 1.79 times 10 to the power minus 5. I need the ethanoic concentration. So I've got the moles and I've got the volume. Yeah, I've got the concentration and I've got the volume, right? So I can figure out the moles, which is what? X times 1, right? Divide by 1000. Okay, it should not be in cm cube, right? So that's X over 1000. What are the moles of this thing? That's concentration times volume, and that's 1 times 100 minus X. It's in cm cube, so it's going to be divided by 1000, right? So 100 minus X divided by 1000 times the H plus 1 concentration. We also know the H plus 1 concentration because the pH was given. So pH was 5.5. So H plus 1 is what? 10 to the power minus 5.5. So this thing is given, and so I just plugged all of those things in my Ka expression. Yeah, I had the moles in terms of X. The concentration was given, the volume was given. I had the moles of this, the concentration was given, and the volume in terms of X was given. The pH was given, so I knew what H plus 1 was, right? And the K value was also given. So all I need to do is I need to solve this question, okay? And solve for X. You are part clear?
Yes.
Okay, Ibrahim, Isaac, Rumesa, Minal, Hala, is this clear?
Yeah.
ये
Sir.
ठीक है इसको अच्छा again to well I'm going to make a comment on this, just a short comment, which is that in A levels what happens is that most of the questions are simple. You got a big paper, 100-mark paper, but then all of a sudden you have these tiny questions popping up like this one, which are like really, really difficult to solve. But the paper ke andar na, I don't think anyone would be able to think so much about a question. So, but most of the questions that you get in your paper are kind of straightforward. 10% Cairo, which would be similar to this one. But we'll practice more questions in the next class then, okay? Chale, okay, everyone. Take care, Allah Hafiz.
Okay, sir. Allah Hafiz.